In Precalculus Lesson 14, we continue graphing rational functions, beginning with graphs containing what we refer to as wholes. This is from section 3.3 in the College Algebra textbook. Let's start with the function f of x equals x plus 4 over x squared minus 16. I will first of all identify the domain. It will help to have f of x factored, the denominator at least, to identify the domain. So x squared minus 16 factors into x minus 4 times x plus 4. Then I can see that the domain excludes x values of negative 4 and 4. The domain is negative infinity to negative 4, union negative 4 to 4, union 4 to infinity, written in interval notation here. We next look for wholes in our graph. To identify wholes, I'm looking for common factors between the numerator and denominator, and if you see here, x plus 4 appears in both the numerator and denominator. I can rewrite f of x as being equal to 1 over x minus 4 by pulling out the factor of x plus 4 over x plus 4, but I have to be careful to make a note here that we still need to exclude negative 4 from our domain of this function. So I need to say f of x equals 1 over x minus 4. X is not equal to negative 4. To find the whole, well, what is happening when x is equal to negative 4 is that we do have a hole in our graph at that point. So the whole occurs at x equals negative 4, and to find the y value at that point on the graph, we would look at our simplified version of f of x here, plug in negative 4 for x. I would have y equals 1 over negative 4 minus 4, or negative 1/8. Our whole then is the point on the graph, negative 4, negative 1/8. Let's next look for the x-intercepts. I use the simplified version of the function to find x-intercepts. An x-intercept occurs when y equals 0, or in this case when f of x equals 0. With a 1 in the numerator, I can see that there is no way that f of x will be equal to 0 here, and so there are no x-intercepts. The y-intercept we identify by setting x equal to 0 in the simplified version of f of x, so y equals 1 over 0 minus 4, or negative 1/4. Thus, we have a y-intercept of 0, negative 1/4. Then we look for asymptotes. For the vertical asymptote, again, looking at the simplified version of f of x, I set the one factor in the denominator equal to 0 and get x equals 4 as a vertical asymptote. The horizontal asymptote, we look at the degree, which is 0, of the numerator over the degree of the denominator, which is 1. Since the degree of the numerator is less than the degree of the denominator, our horizontal asymptote will be y equals 0. Now for graphing, let's locate what we have so far. We have a hole at the point negative 4, negative 1/8. We have a y-intercept, 0, negative 1/4. We have our vertical asymptote, x equals 4, and the horizontal asymptote, y equals 0, which runs along the x-axis here. So what do we need to do? We need to look. There are no x-intercepts here, so I only need to be concerned about the vertical asymptote points to the left and right. To the left of that vertical asymptote, I note that the y-intercept tells me that the graph is totally below the x-axis. So let's go ahead and graph to the left of the vertical asymptote like so. Note that our graph approaches the horizontal asymptote headed to the left. It approaches the vertical asymptote headed to the right, passes through the y-intercept. What's happening to the right of my vertical asymptote? Well, to the right of my vertical asymptote, I need to pay some attention to the factor in the denominator here of x minus 4, from which I get that vertical asymptote. That factor is raised to the odd power of 1, which tells me that the behavior of my graph on the left side, being heading towards negative infinity, is going to change at that vertical asymptote. To the right of the vertical asymptote, my graph will be heading towards positive infinity as it approaches that vertical asymptote. And again, to the right, my graph is approaching the horizontal asymptote of y equals 0. So here we have the graph. One note, the only time we need to be careful of a hole here is should the hole appear on the x-axis, we would have to test points on both sides of that hole, because it would be possible for the graph to cross the x-axis at a hole. Okay, so let's go ahead and look at the first try on your own for this lesson. Find the domain, holes, intercepts, and asymptotes, and then graph the rational function r of x equals x squared plus 3x plus 2 over x squared minus x minus 2.